All right, guys, this is section 1.3 titled Problem Solving, and this is a section that hopefully will help you through the rest of the course in terms of solving all the problems that we're going to be looking at. And so as we do this, we're going to be looking through what is called the Polya's 4 steps in problem solving. So let's get started here in looking at step 1 of those 4 steps is to understand the problem. And one way of doing that is to read the problem several times. The first time is simply an overview just to see what the problem is saying. The second time, write down the important given information that you're seeing in the problem. One way of doing that maybe is to have somebody read the problem to you, and you say stop every time you think that there's something important in the problem. Typically they're numbers, times, those types of things that you're looking for. The third time reading through the problem, make sure that you understand what the problem is asking you exactly to solve. All right? Another way to make sure that you're understanding the problem is that if you can restate the problem in your own words. If you can restate it, then typically you understand what it's asking you. Step 2 is to come up with a plan, to devise a plan, and we're going to go through a list here quickly of all the different possibilities that you could use to solve a problem. One of them is out of the first section that we just finished. Look for a pattern in the problem. Maybe make a systematic list or a chart or a table to help you solve this particular problem. Maybe it's a geometry type problem or something else where a sketch or a diagram would help you to illustrate the problem in order to solve it. Try solving a similar simplified version of the problem. Maybe the problem says out of 1,000 book lockers, such and such. Well, maybe if you reduce that to 100 book lockers or 10 book lockers, maybe you could find the solution within that and then expand it to 1,000. Use the given information in the problem to eliminate possibilities to get to the final conclusion. Look for a catch. Perhaps it's a trick question. And the questions that we're looking at throughout this course, they're math questions. They're not trick questions. And so this is not typically going to be something used here. Make an educated guess and then work backwards in comparison to the given conditions to eventually arrive at the solution. And so that's a possibility to work backwards and make sure that it hits the problem. Use trial and error, not the best method maybe, not the fastest method typically, but as long as it helps you solve the problem. Maybe you solved the problem before that is the same type of problem, and so you can look back at how you solved that one and apply those principles to this one. And maybe this should have been the first step in the list, but use common sense as you're solving the problems that we're looking at. All right, step 3 is to carry out the plan and solve the problem. So once you've devised a plan, you need to carry that plan out, whatever that requires, to solve the problem. Step 4 is to look back and check your answer and make sure that your answer does fit the conditions of the original problem. If not, you need to go back and try a different method or check your work again. Your first few homework questions ask you to find what's missing in terms of a piece of information to solve a problem. So let's look at a couple of examples of that. Here's a question. A man purchased 5 shirts each at the same discounted price. How much did he pay for them? If we look at step 1 in understanding the problem, here's what's given. The number of shirts purchased is 5. That's given in the problem. Step 2, devise a plan. The total amount that he paid for the shirts would be the number of shirts, 5 in this case, times the cost of each shirt. But the cost of each shirt is not given to us. That's the missing piece of information that makes it impossible to solve this problem. Another example, your restaurant bill was $20.36 including tax. How much change did you receive from the cashier? Well, the missing information is the amount of money that you gave the cashier to pay the bill with. Was it a $20 bill and a $1 bill? A 20 and a 5? 20 and a 10? 220? We don't know what you gave the cashier in order to be able to calculate the change that you would receive back. So that's the missing piece of information. It is possible that the problem gives you extra information, and so we're going to look at another problem here where we go through all 4 steps to solve the problem, and in the middle of that we're going to see that there's an extra piece of information. So here's our question. A roll of easy white paper towels contains 100 sheets and costs $1.38. Another brand, Quick Clean, contains 5 dozen sheets per roll and costs $1.23. If you need 3 rolls of paper towels, which brand is the better value? So let's make sure we understand the problem here. Here's what's given. Easy Wipe has 100 sheets per roll and it costs $1.38. Quick Clean has 5 dozen sheets per roll and costs $1.23. We need to buy 3 rolls. All right? Step 2, devise a plan. The better value means the one that has the lowest price per sheet, or in other words, the cheapest one. Therefore, we need to calculate the cost per sheet, also known as the unit price for each brand. It doesn't matter how many rolls you buy, the unit price stays the same. So the number of rolls is the unnecessary information here. We don't need to know that we're buying 3 rolls. It would be the same price no matter how many rolls we buy. So step 3, let's use that plan, carry it out, and solve the problem. So for Easy Wipe, let's calculate how much it costs per sheet. To do that, we would need how much it costs per roll and divide it by how many sheets are in a roll. And so that would be $1.38 for the Easy Wipe divided by 100, which gives us 0.0138, or about 1 cent per sheet, approximately. For the Quick Clean, to calculate the price per sheet, we do the same calculation, price per roll divided by the number of sheets per roll. In this case, that's $1.23, but it said it had 5 dozen. Well, that's 5 times 12. 12 is a dozen. 5 times 12 is 60. So we're going to divide by 60 this time, 60 sheets. That gives us approximately 0.0205, or about 2 cents per sheet. So, by comparing the unit prices, we see that the Easy Wipe is the better value. They're the cheaper, less expensive paper towel here. All right, step 4, and look back and check your answers. So the Easy Wipe, the check was 0.0138 times 100. That gives us $1.38, which was given in the problem. Quick Clean, we'll take the 0.0205 and multiply it by the 60, and that gives us $1.23. Both of those values were given in the original problem, and so there's our check. All right, let's look at another example. Suppose you're a software engineer programming an automatic gate for a toll booth that costs 50 cents to get through the toll booth. The gate needs to accept exact change only, cannot give change, and it won't accept pennies. How many different combinations will you have to program into the gate? So let's look at step 1. We need to understand what the problem's asking. It has to be exact change, such as 2 quarters, 5 dimes, etc. We need to count all the possible combinations of coins other than pennies that add up to 50 cents. Okay? So, step 2, let's devise a plan to do that. The best plan, I believe, here would be to make a list of all those possibilities and then count how many there are. All right, so let's go through and carry out that plan. To systematically list all the possibilities, we'll create a table to keep track of how many half dollars, quarters, dimes, and nickels it takes to make exactly 50 cents. Obviously, so here's our table. So we have a column for half dollars, a column to count how many quarters we need, how many dimes, how many nickels. Okay? Obviously, the easiest way to make 50 cents is with 1 half dollar. So on our table, we would have 1 under the half dollar column, 0 quarters, 0 dimes, 0 nickels. Second easiest way to make 50 cents is with 2 quarters. So on our table, we would have 0 half dollars, 2 quarters, 0 dimes, and 0 nickels. All right? So if we continue with that pattern and look at all the combinations of coming up with 50 cents, here is our table. And this is from your book. Okay? And so you can see the first row is our 1 half dollar. Our second row is our 2 quarters. You could maybe have 1 quarter, 2 dimes, and a nickel, and so on. You can go through this whole table and see all the way down to 10 nickels as a possibility to get to 50 cents. All right? So if we count how many rows there are, because it's how many different combinations we came up with, there are 11 different combinations to come up with 50 cents. Okay, to look back and check your answer, you're going to have to double check the table to make sure that you got every possible combination of half dollars, quarters, dimes, and nickels that add up to 50 cents, and then double check to make sure that the total of each row is 50 cents. And then maybe double check that you did count correctly to get to the 11. All right, another example. Let's solve this problem by using a diagram, and maybe more specifically a tree diagram. Okay, here's our question. 4 runners are in a 1-mile race. Maria, Aretha, Thelma, and Debbie. Points are only awarded to first and second place, with first place getting more points than second place. How many different arrangements of first and second place winners are there? So let's make sure we understand the question. Here are some possibilities. Maybe Maria got first and Aretha got second. Or maybe Maria got first and Thelma got second. Or maybe Aretha got first and Maria got second. And so we need to figure out all the different ways that all these things could happen with those 4 people in first and second place. So it can get confusing. So we need a systematic method in order to solve this problem. So we need to devise a good plan here. So we need to make a list again of all the possible first and second place finishers. To do this systematically so we don't get lost, we will look at each runner winning first place and then each of the other runners winning second place and see how many that adds up to. All right, so here's our table. First place, second place, and the number of possibilities out of each one of those. So let's look first of all with Maria winning first. If Maria wins first, then Aretha could win second, Thelma could win second, or Debbie could win second. So there are 3 different possibilities there with Maria taking first place. All right? Well, maybe Aretha gets first place. If that's the case, then Maria could be in second place, Thelma could be in second place, or Debbie could be in second place. Well, there's another 3 possibilities of what could happen. Well, maybe Thelma got first place. And if that's the case, maybe Maria came in second, Thelma came in second, or Aretha came in second. Again, that would be another 3 possibilities. Or maybe Debbie came in first, and then possibly Maria got second, Aretha got second, or Thelma got second. Again, 3 more possibilities of what could happen. But because we went through every possibility there, of all 4 of them potentially taking first, and the other 3 taking second, those are all the possibilities, and so that would make it 12 different ways that that could happen. So if we look back and check our answer, we double-checked our diagram to make sure that it included every combination of first place winners and then second place winners after that, and then just double-checked our count to come up with the 12 total possibilities there. Another question. You were going to use multiple methods to solve this question. New York City and Washington, D.C. are about 240 miles apart. A car leaves New York City at noon, traveling directly south toward Washington, D.C. at 55 miles per hour. At the same time, a car leaves Washington, D.C. bound for New York City, traveling directly north at 45 miles per hour. How far has each car traveled when the drivers meet for lunch at 2:24 p.m.? Complicated question maybe, so let's break it down. First, let's understand the problem. We need to calculate how far each car travels in a specific time period. That's really what we're doing. How far does each car travel in the time that it takes to get from their respective cities to where they meet at 2:24, or in other words, 2 hours and 24 minutes later? So here's a diagram, possibly to show what we're talking about. The one car drives 55 miles per hour for 2 hours and 24 minutes. And the other car drives 45 miles per hour for 2 hours and 24 minutes. Car coming from New York is going to travel a little bit farther because it's going faster. Step 2, devise a plan. In order to calculate the distance that each car travels, we need to remember that distance equals rate times time, or in other words, as a formula, it's d equals r times t. So for our particular diagram that we just looked at, we would need to multiply 55, the rate, 55 miles per hour, times the 2 hours and 24 minutes. For the second car, we would need to multiply its rate, 45 miles per hour, times its time, 2 hours and 24 minutes. So let's carry out those calculations. So looking at the rate of the first car, the one going from New York City to Washington, D.C., again, it's 55 miles per hour, and the time that that first car is traveling is 2 hours and 24 minutes. A little bit of repetition here, but that's okay. The rate of the second car, going from Washington, D.C. to New York City, is 45 miles per hour, and it's traveling also for the same amount of time, 2 hours and 24 minutes. However, we have to make sure, in order to use our formula, that the rate, because the rate is in miles per hour, we need the time completely in hours, not hours and minutes, but just in hours. So we need to do a little bit of a conversion here. So that 24 minutes is what's throwing us off. So we need to change that to hours. So it would be 24/60ths of an hour, because there's 60 minutes in an hour, so 24/60ths of an hour. And so you could just divide that, 24 divided by 60, or if you want to reduce it first, 6 goes into both of them, and so it would be 4/10, or in other words, 0.4 we would get if we divided 24 by 60, or 4 by 10. And so that means that our time is 2.4 hours to total or to equal 2 hours and 24 minutes. All right, so that's what we're going to use. So going back to our formula, the distance for the first car is rate times time. And so its rate is 55 miles per hour, per in math means division, times the 2.4 hours that we have. So the miles per hour, the hours on the bottom, the 2.4 hours, hours is on top, so the hours cancel, and 55 times 2.4 would be 132, and then miles is what's left over. So the first car travels 132 miles. The distance for the second car, same thing, distance equals rate times time, and so its rate is 45 miles per hour, and its time is 2.4 hours, same time again. If we multiply those, we get 108 miles. So there's the solution to the question. The first car travels 132 miles. The second car travels 108 miles. We can check that multiple ways. We can go the 132 miles for the first car divided by its rate, 55, and that does give us 2.4 hours. And then the 108 miles that the second car travels divided by its rate of 45, that again gives us 2.4 hours. Or we could divide the 132 miles by the 2.4 hours, and that would give us 55 miles per hour. Or the 108 miles for the second car divided by the 2.4 hours, and that would give us 45 miles per hour for it. So any of those would be a way of checking this. Actually, another way, there was a piece of information in the original problem, the 240 miles. It seemed like it was just useless information or extra information, but we actually can use it in the check. Because if the first car went 132 miles and the second car went 108 miles, that does add up to the 240 miles that they originally told us. So it's just another check that we can use. All right, hopefully all these examples and the list of methods will help you to solve some questions on your own as some practice in assignment 1.3 in my math lab. So good luck with that. If you come up with any questions, just email me.